Okay, welcome to Level 1 Science Online with Henny van Vieren.
Hello Year 11s, welcome to another lesson on the whole physics thing for this year. I hope you guys are doing well. We're getting closer to level 2, so soon we will be back in the lab. I'm really looking forward to seeing all of you guys. Anyways, so today we're going to do a lesson on work, and yeah, so without further ado, let's jump into that.
Work. You see me, I be work. You see me.
There we go. So today is all about work. Work can be defined as the force it took to do something and the distance that it moved the thing. Okay, and work is energy, for instance, is the ability to do work, and we know that a force is energy being applied because we measure that in Newton. Okay, so everything is interconnected here, but work is the force times the distance. Now, you guys like that song? I think that was, I'm not even sure the artist is, I think it's Ariana Grande, but this is more from my time. Hi ho! So, work. When a force is applied to an object of mass and continues, um, sorry, when, it, when a force is applied to an object of mass and moves it over a distance, then work has been done. When you move something, you're doing work. If an object does not move, no matter how much force is applied, then no work has been done. So think about it. You're pushing against the car that's got its handbrake up. You cannot move the thing. You are pushing as hard as you can. After a while, you're panting, you're tired, but you have not done any work because the vehicle did not move. So work is proportional to the force applied, the weight force, and the distance traveled. So work is the force multiplied by the distance. And we measure work in a unit called joules. Okay, you've all heard of kilojoules. Comes back to diet. If we eat too many kilojoules and we burn too few kilojoules by doing not enough work, which could be exercise as well, because you can be moving yourself a distance, you can actually work out how much work you have done in joules. Anyway, so to do 1 joule of work, you need 1 joule of energy. So here's your triangle if you need that. Work is force times distance, so work is going to be at the top, and you know how a triangle is made. Now, we also need to remember that this force, when the item is moved in a horizontal plane, then we don't use weight force. Okay, we use the force that it's being pushed. But when it's being moved in a vertical plane, then we use weight force. Okay, so the weight is the downward force due to gravity, and then we have mass times the gravitational acceleration, which is 10 meters per second. Okay, so if the force is due to the weight force, then the distance moved, if traveling up a ramp, will be the vertical distance. Now, this is really important because there's going to be a lot of questions where they are pushing something up a ramp. And when they get to the end, they're going to ask you how much work was done. And the only difference that happened was that it actually went upwards. Hence why in this case you can see the bicycle over there, and you can see the distance that it was lifted is 1.5 meters. So when we do work equals force times distance, this distance is going to be 1.5 meters. It's not going to be the distance from there to there, because it's going to be its weight force in Newton multiplied by the distance. Okay, so here we go. How much work did Chris, 48 kilograms, do when he climbed up the stairs to the 2-meter platform? Okay, so let's think about it. Chris climbed up the 2-meter platform. So did they give us distance? Let me just change that to pen. Yes, they gave us distance. Okay. Did they give us the weight force? No, but they gave us the mass. So the first thing we're going to do is weight force, because this is a vertical movement of 2 meters. Okay, so the weight force is equal to mass times acceleration, which is equal to 48 kilograms multiplied by 10 meters per second squared equals 480 Newton. There we go. Now we have the force and we have the distance. So we can easily say that the work is force times distance equals 480 multiplied by 2 meters equals 960 joules. Okay, easy peasy. Question 1C. And this is for merit. How do you make this? Is so easy for merit. Ian's mass is 52 kilograms. Why did Ian do more work climbing up the 5-meter ladder compared to Chris climbing up the 2-meter ladder? Oh, wow. Okay, so obviously we're going to explain this by working on the formula. So, number 1, the distance is higher. If the distance is bigger, then work will go bigger. Well, it did because it's a multiplication. It's not a division. Okay? So that's quite easy. And because he's got a greater mass, which means he's going to have a greater weight force, which is going to be 520 Newton. And if this goes up, so does work. So we can show them the calculation, and we can say that the force that he used was mass times acceleration equals 52 kgs multiplied by 10 meters per second, and that gives us 520 Newton. Okay, and we put that into our weight equation, not weight, sorry, the work equation. So work equals force times distance, and that is equal to 520 multiplied by 5, which is going to be 5 times 5 is 25, so that's 2,500 plus another 100, so that's 2,600 joules. And there you have explained it if you also worked in your words. Let's look at the model answer. Hopefully I was right, so there we go. So the force, work times distance, forget about this for now, we will get to that later. Okay, 960 joules there, and the answer, work is proportional to the applied weight force and the distance travelled, whereas in the formula and words, work is needed to transfer energy as Ian has more mass and weight as weight force. He also climbs a longer distance. So, and then we can actually put that in there. Alrighty. Easy enough. Here's another for achieved. We did question 3A, and this was in 2014. During the construction of a building, a long beam was lifted into place using a crane. Calculate the work done in lifting the beam with a weight force of 600 Newton through a distance of 50 meters. That's easy. So, they're asking us to calculate work. And we know that work equals weight force times distance. So they've given us the distance, and they have given us the weight force. We don't even have to calculate that. So it's simply 6,000 times 50. And that is going to be, imagine it's 30,000. Joules. I'm doing this out of my head, so I might be wrong, but yeah. Then let's just see Oh, 300,000, sorry. Quick. So I've got 6,000 times 50 equals 300,000. That's why we have calculators, people, so that we don't make silly mistakes like that. Okay, so just there we have achieved. Woohoo! Easy peasy. We don't even have to memorize anything because they give you the equation in the paper. Now, explain why there is no work being done when the beam is hanging in the air without moving. Now, if you are not moving, what is your distance? Your distance is 0. And work equals force times distance. And any number, doesn't matter how big this force is, multiplied by 0 equals 0 joules. Okay? That is why there is no work being done when it's not moving. It doesn't matter how much force is being exerted. Okay, it's almost like saying if there is no unbalanced force on it making it move, then there's no work being done. Alright, so let's just see. So that's 300,000 joules. Work is done when a force causes a beam to move in a direction of the force. The force is not causing the object to move, so no work being done. I think my explanation bringing in the formula was probably a little bit better. Okay, so, but for merit, how easy was that? Here's another one. The horse is racing. Okay, so Sam's horse accelerates for the first 10 seconds. That's up there. And of the race, and covers a distance of 40 meters. Sorry. So 10 seconds. Remember, this is a speed time graph. So in the first 10 seconds, he covered 40 meters. Sam and his horse has a total mass of 308. Use the acceleration to calculate the work that Sam and his horse have done in the first 40 meters. Obviously a trick question, because this is not a vertical question. It is a horizontal question. So we need to figure out the change in, so we need to figure out what the force was pushing this rider and horse horizontally for 40 meters. Okay, so we know that for Sam, and that's the red line, 10 seconds is over there, and his speed, you can read it from the graph, is 8 meters per second. So acceleration equals change in velocity over change in time, and that gives us a change of velocity of 8 meters per second divided by the time, which was 10, and that gives us what is 8 over 10? 0.75, is it? No. So 8 divided by 10 gives us 0.8. 0.8 meters per second squared. Okay, now we have acceleration. Now force equals mass times acceleration. Not g, because we're moving horizontal. So 308 kilograms multiplied by 0.8 meters per second equals 246.4 Newton. Yay, we have the force. May the force be with you. Now, work equals force multiplied by the distance equals 246.4 Newton multiplied by 40 meters. So the work that horse did was 9,856 joules. There we go. Not that complicated when we remember a vertical distance versus a horizontal distance. Okay, don't get confused between the two, please. And you can see they calculated the acceleration and they did the same over here. Okay, question 1c, and this was for excellence. Explain the effect of on work and power if a new, heavier jockey was on Sam's horse, which had the same speed and acceleration over them. So, again, we can go back to all the formula that we used in that previous one. So, firstly, if he has increased mass, it's not a good color. If you increase his mass, because force equals mass times acceleration, his force will go up. And if we have increased force, we will have increased work, because work is force multiplied by the distance. And the distance did not change, so we cannot bring that into the acceleration of change in speed over change in time, but we can bring it in here, and then from there we take the force and we put it into that. Okay, there we go. So work is proportional to the force and distance. Work is needed to transfer the energy. If there's a heavier jockey, there will be more weight force, more energy transferred, therefore more work done. The work used by the heavier jockey is greater, but the same time taken to cover the same distance and the same speed, acceleration, and so forth. So the work has to be greater. And that is the end of work. So thank you so much for your time. Please go and do those SciPad pages, and I will speak to you soon. Thank you guys. Bye.